So hello everyone. Today we will be presenting our project, which is application of derivative in bioscience by using a GitHub webpage that each of us has made.
So I will present my webpage first. My name is Muhammad HAZLAMI bin Muhammad AZMAN, and I am an undergraduate student in SFASFH, which is Animal Husbandry. So my web application is titled Poultry Growth Dynamics, a Biocalculus Visualization. So the bioscience problem that I choose is monitoring broiler chicken growth rate over time. In poultry farming, farmers need to understand how fast chicken gain weight during different stages of development. The challenges is the chicken growth is not constant. Growth changes every day, and farmers must determine the most efficient growth period. So, to solve this problem, I use a logistic growth function, fx, which represents the estimated body weight of the chicken over time, and the derivative, which represents the instantaneous growth rate. So, the importance of studying this bioscience problem is that it directly affects feed efficiency, production costs, harvesting decisions, and farm profitability. So, for example, if farmers know the period of maximum growth, they can optimize feeding strategies and reduce unnecessary feed waste. The derivative helps to identify when the growth is increasing rapidly, when it reaches its peak, and when the growth begins to slow down. This is very important in Malaysia's poultry industry because feed cost is one of the largest production expenses. By applying calculus in animal husbandry, farmers can make more scientific and data-driven decisions. So now I will demonstrate the interactive graph. As you can see, the first point that I have clicked is a very early stages where the green line indicates the chicken weight and the green dotted line indicates its derivative, which is the growth rate per day. And the orange line is a tangent line where when it becomes stiff, the stiffer it becomes, the higher the growth rate, and less stiffer means lower growth rate. At this early growth stage, as you can see, everything is so low, which means the chicken is still young, body weight is low, and the derivative value is small, which translates into the chicken is still adapting and developing basic body structures. So the next point that I'm going to click, as you can see, in this point, it's called inflection point, where it shows the highest derivative value. As you can see, the tangent line is very stiff, which means the derivative is at its peak. And the chicken is gaining weight at the fastest rate. Here, muscle growth is very active and feed conversion is highly efficient. So the next point I'm going to show you, this is the late growth stage, which is, as you can see, the weight is very high, but the derivative, which is the rate growth, is very low, which means the chicken is approaching maturity. Even though feed consumption continues increasing, weight gain becomes less efficient. Okay, so next is my recommendation to improve this HTML application. So I think there's always a room for improvement, and the best improvement that I could add to my web page is adding a real-time feed conversion ratio simulation, which, for example, users could adjust feed amount using sliders, and the graph would dynamically update growth rate predictions. This would make the application more realistic, more interactive, and more relevant to modern smart farming systems. It would also strengthen the connection between bioscience, mathematics, and precision agriculture technology. In conclusion, we can better understand poultry growth patterns and improve farm management decisions scientifically. This project demonstrates that calculus is not only theoretical mathematics, but also a practical tool used in bioscience and animal husbandry. That's all from me. Thank you.
Okay, hi everyone. My name is Song Cheng Hui, and then I'm from course SFASFH. Today, I'm going to represent a bioscience problem which is related to the Kedah-Kelantan cattle. So this is my GitHub website. It shows the Kedah-Kelantan cattle growth derivative analysis. First of all, we can see that the Kedah-Kelantan cattle is also known as a KK cattle. It is an important local breed in Malaysia, and it is highly adapted to the tropical climates and the high humidity environment of our country. So it gives a good reproductive performance. In this website, the function fx is going to calculate the cumulative cattle body weight at each x, which is a month, and also the derivative f prime x will calculate the instantaneous growth rate in kg per month. The derivative could help us to identify the biologically optimal growth phase for efficient beef production. So why this topic is important for us to learn, as the farmer and the researchers can use this data to study and predict the cattle growth. By understanding the growth rate and also the derivative patterns, the farmer can identify the best feeding period and also the management strategy for the cattle. So now I'm going to present about the growth curve for the Kedah-Kelantan cattle. So from this curve, we can see that the age is represented from the 0 month until the 36 month. There are several phases and different stages happening in this curve. For the first stage, which is the calf stage, from 1 month until 6 months is the calf stage. We can see that the fx, which is the body weight, is slightly increasing. For the growth rate, it shows a steep upward curve. It means that the calf is having a growth rapidly during these phases, as they need the high nutrient and energy for the bone development, muscle formation, and also the organ growth. The next, which is the juvenile stage, is happen from 6 months until 12 months. Yeah, 6 months until 12 months. The body weight of the cattle is still slightly increased, and the growth rate is also showing a steep curve. So the body weight increase faster and faster because the feed efficiency during this phase is very high. So it is an important stage for the farmers because proper feeding and management can really improve their body weight gain. After this, it shows a growth phase for the cattle is in between the 12 months until the 20 months. The cattle is still having the growth and the body weight increase more better in these phases. During the 18 months, it is an inflection point which showed that the cattle have reached their maximum growth rate and the derivative value will become the highest in this month. After this point, the growth will decelerate. You see the growth rate is slightly decreases, but the body weight is still increasing. It can help us to determine the optimal feeding strategy and also the production planning. After the 20 months, in between 20 to 28 months, there is a transitional finish phase for the cattle. We can see that the cattle is going to become mature in between this time. The growing rate is decreased, but the body weight still increased. So until the above of the 28 months, the cattle finally reach the mature growth phases. At the mature stage, the cattle nearly reach their maximum body size. Yeah, the body size is increased. So the derivative value is decreasing, and decreasing. At this stage, the energy is mainly used for the maintenance and normal body function instead of rapid growth. So the muscle is not going to grow anymore, but the energy is for the maintenance of the body. Coming back to the market optimization, the Malaysia beef system is normally at the target age between 24 to 30 months. As beyond this period, the maintenance energy cost increased substantially while the biological growth efficiency declined. So this is the best way for the cattle to export their meats. So last thing, which is how can I make my HTML to be more better? In my opinion, I think this HTML can add more information about the cattle or maybe give a different species of a cattle for a good comparison with the Kedah Kelantan cattle so that people can easily understand and also compare between these two cattle which one is more better to improve the livestock management. That's all from me. Thank you.
Hello, my name is FADIUS, and my course is SFA. Today, I will present my HTML project type, and the title is Soil and Environmental Simulator. This project focuses on mathematical modeling of pandan plant growth using a calculus approach. And now we go to summary of a problem and important. The bioscience problem I chose is from the agriculture sector. The name is predicting the right maturity time and fertilization cycle for pandan coconut. In Malaysia, pandan coconut has a higher economic value. Why is this project important? Because in the agriculture industry, we cannot just guess. To produce strong tree structure and quality fruit, nitrogen fertilizers need to be given at the right time of the peak vegetative growth rate. Therefore, uh, therefore, we use a logistic function to accurately map this biological timeline, thus optimize cost and crop use. And now, let's see how HTML application work interactively. On the top, on the left, we can see the architect scenario. The background of the study update from the MOHD manual is displayed. Along with the logistic function calculus formula use. On the top, we can see the soil and environmental simulator. There is an interactive slider. We can change the parameter according to the actual condition in the farm, such as the maximum height of the tree and the grow rate and the peak grow a year. On the bottom, we can see the graph, and this graph will be changed dynamically. The green line that show the cumulative of the height, while the blue one is the instantaneous growth rate of first derivative. When I click on any part of a curve, we can see the system will continue to extract the mathematical and biological value of that year in the real time. In closing, my suggestion for improving this HTML fetch is in the future, it is provide and export data to SCV button. With this function, the data they can have the data. They can download the graphical coordinate data. They have to simulate directly into the Excel file for future analysis. And overall, this simulator successfully combined elements of bioscience and mathematical in one easier, accessible digital platform. That's all from me.
Hello everyone, and good day to my lecturer and friends. My name is Nurul BINTI MOHAMAD. I'm from SFA course. Today I am going to present about my project, which is the MD2 Pineapple Bio Calculation Simulator. So, in this presentation, I will explain how we can use calculus to understand and track the growth of MD2 pineapple from day 0 until harvest day. Okay, let's start with the bioscience problems in agriculture, especially for MD2 pineapples. Farmers face big challenges. They do not know the X times when the fruit is growing the fastest, and they cannot accurately predict the fruit which before harvesting. Traditional farmers just guess or estimates based on experience, but this is not accurate. The real biological problems here is understand the dynamic growth rate of the fruit biomass. Growth is not a straight line, it's change every single day. Therefore, we need a mathematical model, especially using calculation derivatives to calculate the internal growth rate of the pineapple. So, why it's important to study these problems? First, optimal harvest the times. By know the egg grow patterns, farmers can plan the perfect harvest days, which is usually around the 114. This ensure the best fruit qualities and sweetness. Second, resources management. When we know when the fruit grow the fastest, farming can apply fertilizers and water at the right time to maximum growth. The third, economy planning. Food industries can add times to total wings of the year early, making it easy to arrange transport and sales. Now, let's look at the simulator graph. The graph has two curves. The solid line, this is a solid line, represents the fruit mass fx in grams, and the dashed line, this is dashed lines, represents the growth rates fx in gram per day. So the x-axis show the day after forcing DAF. This is, and then let's look at the key points based on our simulator. Day 0, this is the started points. The fruit biomass is almost 0 and the growth rate is very low because the development is just starting. And then day 70, then 70, as you can see on the slide, day 70 is the middle phase. At this stage, the fruit wings liner start to curve upwards quickly. This is where the biological acceleration happens. And then day 84, and then day 84, if we look at the plot of data for day 84, the fruit wings f of X is 1,215.7.24 grams. So you see that, and then at this exact moments, the instance growth rate f primes of X is 22.75 grams per day. This means as day 84, the pineapple is adding around 22.75 grams of wings every single day. This is near the peak performance of the fruit groves. And then day 140, after the peak around day 18 to 19, the growth rates start to slow down, and you can see, and the fruit mass curve becomes flat. This tells us the fruit has reached a full maturity and is ready to be harvested. Okay. So finally, how can we make this HTML simulator better? My recommended is to add an interactive what-if input section for environmentally factors. Right now, the simulator only show one fixed ideas grow curve. In real life, with the soil pH and fertilizers amounts change the growth. If we can add drop down menus or input box, which users can select high fertilizers or low rainfall, the calculus equation can adjust automatically. This will make the simulator much more useful for real farmers in the field. In conclusion, this simulator successfully combines biology and calculus to help use see and calculus pineapple grows clearly. That's all for me. Thank you.
So that concludes our presentation for today. Thank you so much. Bye.